So Qwen 3.8 27 billion parameter local AI model has been out for a few days now, and I've been testing it to see what it is capable of. And I've been surprised on how well it is performing, especially compared to the models that we had, just a few weeks ago. This is another major step change in what you can achieve locally on local hardware without having to send everything up into the cloud. That's the topic of today's video. So if you want to find out more, please let me explain. So Qwen 3.8 is a 27 billion parameter model. Now at its full size at 16-bit floating point numbers, it's a 55 gigabyte download, and you're probably going to need 128 gigabytes of RAM to run it, which is beyond what most people have. That's VRAM, beyond what most people have kind of at home, even with a very good gaming setup. However, if you do have something like an RTX 5090 or something else with 32 gigabytes of VRAM, then the 4-bit quantized version of Qwen 3.8 27 billion is runnable on your local PC, and actually at a fairly decent rate. I was getting 96 tokens a second running it on an RTX 5090. That means you can run it locally on your PC and do everything you'd want to do with a normal large language model out in the cloud, but now you're running it locally. And I've been testing it specifically for how good is it at doing coding using open code as the coding harness. But first, let's start with a few simple things. Does it answer the Alice question? Yes, it does. No problem, as you would expect. Does it handle the 7-minute egg timer and the 11-minute egg timer question? Yes, it does. No problem. So now those are out of the way, we can kind of get a feel for the kind of capabilities of this model. Let's push it a little further. The first thing I did, because I wanted a bit of fun, was to get it to create a Space Invaders game using a single HTML file, using inline JavaScript and no external libraries. So this is just had to create everything itself inside of the HTML file. It did that. It produced me index.html. You can double click it and you get a nice Space Invaders game. So I wanted to push it a bit more, so I used my protocol encoding, type length value encoding question, asked it to create a specification similar to ASN1, similar to Google's protobuf. Now it created that specification no trouble. There were a few tiny mistakes in it. It did all the specification defining how the protocol should be laid out, but then at the very end it gives some working examples. This is what happens if you want to encode an integer, this is what happens if you want to encode a string, and actually one of those or two of those had a minor error in the numbers it was telling you that you should use. So the examples it was giving didn't actually quite work out, but if you fix those, no problem whatsoever. So I then went on to say, well, now implemented including testing, including end-to-end testing, unit testing and so on, and I did open code, let it run. A few times I had to interact with it, telling it, you know, here's a plan, this is what you should do, now go ahead and do it, and just as you would do with normal coding with a harness, and it worked perfectly. It gave me a nice little library that could implement the specification, including some end-to-end testing, including some unit tests. Worked absolutely fine. So my big test after that, as I've done in several other videos here on this channel, is my new Scrippy programming language. So the idea is I just give it a example of the new scripting language and even define it formally. I tell it a little bit about it, like it doesn't use semicolons. I tell it it's an interpreter, and I tell it it's written in C, and then I say, go ahead, knock yourself out, go and write the interpreter for this language. Now that's quite a tall order because there's no formal specification for the language, just an example code, and a lot of the stuff it has to kind of infer from the example code and infer from what I've said in the bit of text. Now I've tried this before in other videos, and really local models weren't able to do it. Even Qwen 3.6, they weren't able to do it. They kind of either got stuck in a loop, just not being able to finish it, or what they produced crashed all the time, had severe memory leaks. It was a bit of a disaster. However, the amazing news is here is that in a relatively short amount of time, certainly wasn't even overnight, just a few hours, again, a few promptings, there was a plan, and then we went through the different steps on how to implement it, and then, you know, I said also write some documentation, and I told it all the stuff, back and forth as you would with a coding harness. It worked. Absolutely worked. You can run new Scrippy. It created its own set of test scripts to run as well, and the example script that I gave it for the README file, that runs. And so there you go. This local LLM running on a PC Qwen 3.8 was able to do all of that coding using open code. You could use other harnesses as well, I'm sure. Haven't tested them specifically, but I'm sure it'll be just as good. And it did it all for me, and it actually works. So this is really amazing that we've reached this point. And I'm sure things are going to get better. But this is amazing that we've reached this point for local LLMs, just the power and the capabilities that they have. Okay, I'd love to hear your thoughts in the comments. Have you tried Qwen 3.8? Do you use local AI for coding, or do you only rely on the big models? Do you not do any coding on it? Love to hear your thoughts in the comments below. Okay, that's it. I'll see you in the next one.